Hey guys, welcome to Basic Advanced Math, the channel where I'm trying to take complex math concepts and explain them in a way that's more easily understandable. I get it, math can really suck sometimes. I've been there, it's pretty terrible. But you can do it, and I'm here to try and help you guys understand the concepts that go along with it and really get a good understanding of it so you can really apply everything you know and kill whatever you gotta do. So today we're starting out a series on Calculus BC, aka Calc 2. I'm going to be starting out, we're doing solids of revolution today, arc lengths, and the work going tanks. So yeah, let's get right into it. The first order is going to be solids of revolution. Let's get that started. We are starting off with solids of revolution. What is that, you may ask? I'm about to explain it to you somewhat briefly. I'm going to show you how to solve it in multiple different ways. So let me draw a graph real quick. Alright, so here we have the coordinate plane. We have the line right here. We'll call this y equals 1/2 x. We'll call this x equals 3. So what is a solid of revolution, you may ask? Solid of revolution is basically, if we were to take this triangle right here, formed by the x-axis, x equals 3 line, and y equals 1/2 x line, if we were to rotate this around, say, the x-axis, what shape would it form? It would form a cone. Just rotate it all the way around, filling in all the space, it'll form a cone. We could do the same thing taking this triangle and rotating it around the y-axis. What shape would it form? I have no idea. It's like a circle with a divot in it, I guess. What would the volume of that shape be? That's what solids of revolution is all about. It's more of a real world application. Say you're designing a product or building infrastructure. This is very important. You can easily find the volume of what this shape would be. The first method we're going to look at is called the disk method. Basically what this is, say we're revolving it around the x-axis. So basically what this is, you just had this rectangle and you were to revolve this rectangle around the x-axis by itself. It would look something like this, probably right here, one right here, one right here. I'm very bad at drawing. However, you can imagine you rotate this around the x-axis, it is going to form a disk, just like a CD, literally any other disk from your normal life. We can find the shape of a disk pretty easily. All it is just pi r squared. We take the volume of this disk and we got to do it at every single point across the x-axis. We go all the way across and we will eventually find the volume of this entire cone that we make when revolving it around the x-axis. And that's exactly what the disk method does. So the formula for disk method, we know that the formula for disk is pi r squared. Now what we have to do is we have to take it all the way around the x-axis. The overall basic formula is you can just throw the pi outside of the integral. We'll say pi times the integral from a to b of r squared dh. This may look very scary right now. The first time I saw it, I was like, what on earth is going on? I'm about to fail this entire class. But that didn't happen because we got it on the grind and we learned this stuff. So basically, what do we have to solve for here? We have to solve for a and b. We have to solve for r. And we have to understand what dh is, all right? Because you're not going to be plugging in dh. It's either going to be dx or dy. That's the first thing I would solve. So here, we're going across the x-axis. Every time the disk moves, we move across the x-axis. We're finding the area of vertically, but we don't find the area horizontally. So because we're moving across the x-axis every time, the change that we're changing in, we're changing the x-axis every single time that we move across. Every new disk we find, we change x, so we're going to have a dx. That's the easiest part. We can throw the pi out here as a constant. Now we still have a, b, and r to solve for. Let's solve for r first. That's probably the most difficult part. Now, r is the radius of this disk. What would the radius of this disk be? We got to try and use algebra to figure out what the disk is, maybe some geometry, whatever you want to do. So the height of this triangle is the radius. What is the height at any point during this triangle? Well, the only slope affecting the height of the triangle is y equals 1/2 x. So the radius of this disk is going to be 1/2 x. And that's it. There's no other slope affecting it. There's nothing else happening. So r is going to be 1/2 x. Of course, we got to square that for the formula. So we are going to get 1/4 x squared, as that's 1/2 x squared. So we write that down. We're almost done. Now, what is a and b? A and b is where you take the integral from. So as we're going across the x-axis, we already saying that we're changing x. How far are we changing x? That's a and b. Where does x start and where does x end? X starts clearly at 0. We start taking the volume at 0x. The bottom point of the integral is going to be 0. Now we say, how far do we go out to the other side? What's the highest that we're ever going to go? We're still changing them on the x-axis. As you see, I had to redraw everything. We're still changing them on the x-axis. And how far out do we go? We go to x equals 3. The shape stops when we get to x equals 3. The integral is going to be from 0 to 3. Now we have the entire integral set up. How do you solve this? That's Calc 1 stuff. It's pretty basic. Either plug it into the calculator or solve it yourself. Really doesn't matter. You have everything you need. All you need to know is that formula and how to figure out how to draw the graph and solve for the variables. Once you got all of that down, you are good for this. You solve the integral, and that is the volume of that shape using the disk method. All right, guys. Now we're going to move into the second method, which is called the shell method. It's very similar to the disk method. All you do is you just flip it sideways and you change the shape of the shape that you're going to be taking the volume of, if that makes sense. I'll show it to you, of course. So basically, instead of going vertically across it, now we're still going around the x-axis, right? The disk method is where whatever axis you're going on, you go horizontal to that. However, now we're doing the shell method. Not all the rectangles are going to be touching the x-axis because we're still flipping around it. And the rectangles are all going to look like this. Basically, the same exact thing. All you do is you flip the shell around. Hopefully I can draw this one better than the last one. That is probably more easily to look at. Easier. That is probably easier to look at. So basically all this is you take the area of this rectangle, you rotate it around, and it creates kind of like a tube, like a straw, a really, really thin one, of course, because it's infinitely small essentially is the goal. So as we go down the y-axis, we are going to do every single rectangle possible and eventually hit every area in the cone, and we are going to make a cone that way. So the formula for shell is a little bit more intimidating, but it's just as easy, if not easier. All it is you have the 2 pi, which is a constant. You can take it outside of the integral, and it makes everything easier. So you start out 2 pi. You have the integral from a to b of r h times dr. You notice that it's dr this time instead of dh. You have another variable instead of just the h, which would be squared in the last one. You have rh, and you have 2 pi instead of pi. So we're going to start off with dr, as we always do. We start off with whatever's changing. We notice that we're taking the rectangle here, and we're taking the rectangle a little bit lower, and a little bit lower. This is going to be dy, because every time we take the area of a new straw, we're going down the y-axis. Every time we jump down. So this is going to be dy. That's simple. That's the easiest part. We'd also throw the 2 pi and the integral out here, and we're on our way. What do we do next? We should solve probably, we'll go r. No. We are going to solve for the h next. We're going out of boundaries with this one. What is h? This is where you have to take the algebra, geometry, you have to put it together, and you have to solve how long the straw is going to be every single time that you find the volume for it. So we are going to take the very right side of the straw, and we're going to subtract the very left side of the straw. And that'll tell us how long it is. It seems simple, The very right side is 3. The very right side is always going to be 3. So we can just throw 3 down. 3 minus, because it's the right side minus the left side. What is the left side? Well, this slope is always the left side of the graph. You may say, so the left side is 1/2 x. It's close, but it's not it. Because you see, it's dy. The variable that we want to have in our equation is y. So what do we have to do? We have to solve y equals 1/2 x in terms of y. That's actually pretty easy. X equals 2y. So now we have a radius is always going to be 3 minus 2y. And that is it. That's the height. What's next? We are going to find out the radius. We have dr, we have r. It's the easiest part of this equation by far. What's dr? dy. What is r? Y. That's literally it. We throw y right there. That's it. The only thing we have left is to find where the equation starts and where it stops. The integral starts, we're changing y. What's the lowest y that we have? Again, it's 0. The bottom of the triangle is 0. So we're going to start at 0. We can see that clearly y equals 1/2 x. The top of how high we're going is going to be where the 2 meet, because this is positive, this goes straight up and down. So where they meet is going to be plugging x equals 3 to y equals 1/2 x. You get y equals 1/2 times 3, which is 1/2, or it equals 1/2. So all you have to do is know this formula. You can draw the graph. All you have to do is plug it in. You got to figure out what's what, and then you're done. You plug this into the calculator. You solve it however you want to. All you have to remember is the basic steps, and you are on your way. This video is getting pretty long, so the other two that we talked about, arc length and the work filling up tanks of whatever it is, those two are going to be in the next video. This video is just solids of revolution. Hope you guys understood what I was talking about. If you have any questions, let me know. Get the brain power, bro. Get it. Let's go.